It's just being posted for our class, not for anyone else, but okay. So we missed the first problem, but we'll get through others. So another question you guys want to look at?
Could you do question 18 from 1.4?
Yeah. Okay, so here's question 18 from 1.4. The velocity in centimeters per second of blood in an artery at a distance of x centimeters from the center of the artery can be modeled by this function. So this sort of tells me that, all right, the blood flowing isn't always the same, and because I'm subtracting x as I move away from the center, it moves slower. So what we're seeing is the blood in the middle moves the fastest, and the blood that's bouncing along the edge of the artery is going to slow down a little bit. All right, find a formula for the inverse function. So what we do when we find the inverse is the input and outputs swap roles. So here I have v equals 500 times 0.04 minus x squared. And I've solved for v, so I have v as a function of x. The inverse is going to be x as a function of v, and that's what they're sort of giving you with this notation here. X equals, and we have this inverse function where the input variable is v. So what I want to do is I want to algebraically solve this for x, right? So we can start by dividing both sides by 500. So v over 500 equals 0.04 minus x squared. Okay, I want to get the x by itself, so I want to peel away the extra layers. So I subtract 0.04 from both sides. Okay, so negative 0.04 plus v over 500 is negative x squared. Maybe multiply both sides by -1. Okay, and then I'm going to take the square root of both sides. So x is the square root of 0.04 minus v over 500. Okay, now when we take the square root, we want to do plus and minus normally. However, I can see in my domain for the original function that x is a positive number, so I want x to be positive value. So I just want the positive square root here, so I'm not going to use the negative square root. Okay. And we could actually clean this up a little bit. If I get a common denominator on the inside, multiply 0.04 by 500 over 500. 0.04 times 500, I think, is 20. So we get 20 minus v over 500, and that looks a little nicer. Okay, so that's what I'm going to put for my inverse function. Okay. Next, write the domain of the inverse function. So when I started this, I have a function, and I'm given a limited domain for my original function. Okay, and I can find the range then of this function. A function and its inverse swap the roles of domain and range. So if I look at v equals f of x, the domain is that x is between 0 and 0.2. So then if I find the range, okay, if I plug 0 into this function, I'm going to get 500 times 0.04, which is 20. And if I put 0.2 into this function, get my calculator real quick, 500 times parentheses 0.04 minus 0.2 squared. Okay, then I get 0. So v is going to be between 0 and 20. So then when I go to look at the inverse function, so x equals f inverse of v, the domain is going to be v is between 0 and 20, and then the range, which we don't need here, but I'll write it down anyway, is going to be that x is between 0 and 0.2. Okay. So in interval notation, it would be 0 to 20, including both. Interpret what the inverse function is used for. So for my original function, you're inputting x. So you input the distance from the center and it outputs velocity. So the original function is used to find the velocity of the blood, right? If I know how far it is from the center. The inverse function says this will tell you how far from the center it is or where the blood is if I input velocity. Okay, so it tells me where the distance, where is the blood or the distance from the center of the artery if I know what the velocity of the blood is. Okay, and finally, find the distance from the center of an artery with a velocity of 18. So we're given v equals 18. We want to find x. So if I want to find x, I want to use my x equals equation, right, which is the inverse function, and I just plug in 18 for v.
Okay.
I think for this one, if I get something like this. I'm sorry, I couldn't understand that. What did you say? I don't know if it's on my end or your end, but the speech is really garbled there. Could you try typing the question in chat? So when I don't have any context on my question, right? So if we had a question that just said, something like y equals, 3x squared plus 4, find the inverse, we typically want to write y as a function of x. So what you often do is at the beginning, you switch the x and y. You write x equals 3y squared plus 4, and then solve for y because you're used to seeing y equals. However, if I have context on it, right, the reason we write v is because that stands for velocity, right? And so we want to leave that as, v is velocity. We don't want to swap x and y because then v would be distance and x would be velocity, and that doesn't make sense anymore. So if there's context on our function, on one or both of our variables, then we don't swap the two, but we still solve for the other variable, right? So here, I would be solving for y. We just didn't swap the two, but we're still solving for the variable that's, that was the independent variable. So yeah, you're right. If you remember back to finding inverses, typically swap x and y's and then solve for y. If you skip that first step where you swap x and y, though, you're just solving for the x then.
Thank you.
Okay, another homework question?
How about question 24 from 1.5?
Okay, here's 1.5, question 24. Blood is a buffer solution. When carbon dioxide is absorbed into the bloodstream, it produces carbonic acid and lowers the pH. The body compensates by producing bicarbonate, a weak base, to partially neutralize the acid. The equation which models blood pH in this situation is, we have pH as a function of x, 6.1 plus log. Just a side note, typically when we write log and we don't write a base on there, it's understood that that's going to be log base 10. Okay, so we have log base 10 of 800 over x, where x is the partial pressure of carbon dioxide in arterial blood, measured in torr. Find the partial pressure of carbon dioxide in the arterial blood if pH is 7.3. So x is this partial pressure. and it's saying find the partial pressure. So what we want to do is find X if the pH is 7.3. Okay. So if I just plug that stuff in, I replace pH with 7.3, and I want to solve for X. So let's just kind of strip the layers away. So we subtract 6.1 from both sides. So 1.2 equals log base 10 of 800 over X. And now in order to get rid of the log base 10, we have to use the inverse function. So the inverse of log base 10 is the exponential base 10. And the way that we get rid of inverses is by composition, right? We plug these both sides into our inverse, right? So I'm going to take 10 to the power of both sides. So 10 to the power of 1.2. I'll go ahead and use my calculator to approximate that. I get 15.8489. And on this side, 10 to the power of log base 10 of stuff will just give me that inside stuff. Okay, so now I multiply both sides by X, and then divide both sides by that 15.8489. Now, on my calculator, I'm not actually typing 15.8489. When I did 10 to the power of 1.2, maybe I can show this on my calculator, I'm going to let my calculator keep all of the decimal places so that I don't lose anything along the way. Okay, so we said we had 10 to the power of 1.2. Okay, and I got that number, and then we ended up doing 800 divided by that number. So I just grab it, and that way I keep all of the decimal places, and then I don't introduce rounding error until I round at the very end. So I end up with 50.48 if I round it to 2 places. Okay, and I wonder, it might mark me wrong. It doesn't say how far to round to in this one, but 2 places it took.
Yeah, I was going to ask, is there a certain decimal place we should be rounding to if it's not explicitly stated in the question?
No, if it should be explicitly stated. If it's not, you kind of have to just use your best judgment. Typically, what I think of is what would be convenient, and then go like 1 or 2 decimal places more than that.
Okay.
If you did a problem and you feel like you did it right, or like you type in a number and then when it shows you the answer at the end, and you just rounded wrong, instead of redoing the whole problem, you can just message me and say, like, it didn't say how far to round, I rounded too much, and then I'll just go back and give you the points.
Okay. Well, I've got 2 more from 1.5, and then that's all I've got.
All right.
19 and 20, unless anyone else has something.
I have a couple from a different section. So.
Okay, well, let's do these 2, and then we'll go to another section. Solve exactly, so no rounding here. Log base 7 of negative 4x equals log base 7 of 2. Solve for x. So what we're going to do, somewhat similar to what we did before, to get the x by itself, I need to get rid of the log base 7. So I'm going to use, I'm sorry, this was question 19, I think.
Yep.
From 1.5. Okay, I need to get rid of this log base 7. Now, this question is a little bit convenient because I have log base 7 on both sides, okay? But I'm going to do the same thing. I take 7 to the power of both sides. Since I have a log base 7 and an exponential base 7, when I compose them, they cancel. So I just get negative 4x equals 2, and then I divide. Right, now that an x is negative 1/2. Okay. Yeah,
Okay.
and I think for this question the logs will always match. Yeah, so somewhat similar here. Yeah, so if the logs are on both sides are the same, they cancel. Now, one thing that I'm gonna answer that question, but I want to be careful about answering it because the question you get here is not what you'll always get. If I had something like this, log base 2 of negative 6x plus 3 equals log base 2 of 15 plus 1, then I need to be careful they don't just immediately cancel, because I take 2 to the power of the left-hand side and 2 to the power of the right-hand side. And here, it's just a log and an exponential. There's nothing else. They cancel. But if I'm adding other stuff, they don't cancel. Okay. Just like square roots and squareds, right? If I had like x squared plus 4 and I square root it, that square root and the x squared don't cancel because of the plus 4, right? It messes it up. So here what I need to do is I need to break this up first, and I can use the properties of exponentials. If I have 2 to the power of a plus b, that's 2 to the a, not plus, times 2 to the b. So this would be 2 to the log base 2 of 15 times 2 to the 1, and then here my log and exponential would cancel. So I would get just the 15, and then 2 to the 1 is times 2. Okay, so you can still solve it if there were other things, you just have to be a little bit more careful about them canceling. But if it is just a log on both sides, they cancel. The reason that they cancel is because log is a one-to-one function.
Okay.
Thank you.
Okay.
Is my mic working?
Yes, it is working now.
Okay, thank you.
Okay, was that the two that we wanted from this section? I thought it was 19 and 20.
Yeah, 19 and 20.
Okay. And I think this one was 20. Or am I wrong? Nope. This one is 20. Okay. Find the time it takes for $6,900 to double when invested at an annual rate of 3% compounded continuously. So a quick side note on interest, compounded continuously is not something that banks really use. It's something that economists use. And the reason that economists use it is because the math works out nicer. But it kind of sounds confusing. Like, how do you have interest compounded continuously, right? But it's, it is a thing. All right. So the idea is that if it's compounded continuously, and I think that they give you an example of this in your book. I think they typically write the formula this way. You can change the names of the variables, but I think of like A as your amount of money. The P, sometimes it's a P0, or it may just be written as a P. Again, that doesn't really matter a whole lot. But that's the principal or starting amount. Then you have your exponential. Then you have your K, which is the rate, and then T is the time. Okay, so find the time it takes to double when invested at an annual interest rate of 3%. Okay, so whatever amount I start with P, I'm going to end with double P. And my interest rate is 3%. So as a decimal, that's 0.03. And then I just have, my T, and I want to find the amount of time. So we're going to solve for T. Okay, and if I start by dividing both sides by P, I end up with 2 equals e to the 0.03 times T. Okay, to get rid of an exponential base e, I'm going to use the inverse, which is a logarithm base e, right, which we write as natural log. So take natural log of both sides. So I'll write this, but they just cancel away, right? Natural log of e to stuff just gives me that inside stuff. Okay, so to solve for t, I just divide both sides by 0.03. So ln of 2 over 0.03 is that time it takes to double. And I'll just go ahead and plug that into my calculator. Okay, and we get 23.1 years. Okay. If I change the amount, oh, I'm sorry. I did this wrong in a sense. We had an amount. I didn't have to leave it as P. I did this. What I did is I ended up solving this for any amount, right? So you can see that the two answers are going to be the same because whatever your starting amount is, right? The time it takes to double is the same. Maybe I should have been a little bit more careful in reading the problem because we have the original amount. The ending amount would be double this, right? So I would take my $6,900 and double it.
They still end up canceling though, right?
Yeah. Yeah, so we would get 13,800 equals 6,900 times e to the 0.03t. And then when you divide both sides by 6,900, you'll get 2. Same thing, if you change the amount, that doesn't matter. Once you divide both sides by that, you'll just end up with 2 because it's, the ending amount is exactly double, right? So you'll get back to this spot either way. So you get the same time. Okay. What's the next question we're going to look at? I think we're going to go to another section.
Yeah, it's 2.1 number 9.
The following table shows daily receipts in millions of dollars of the movie Avatar for successive Fridays after its opening on Friday 18th, December 2009. Okay, so this is the number of weeks, this is the receipts. Estimate the instantaneous rate of change of daily receipts 8 weeks after opening day, round to 4 places. So what we're given here is if I think of my weeks as being an input variable X and the receipts in dollars as being an output variable Y, I'm given a bunch of XY points. I don't have a formula for this function. I just have all of these XY points, right? And what we're doing is we're trying to say if there were, suppose there's some underlying function in here, find the instantaneous rate of change or the slope of the tangent line, right, at an X value of 8. Okay, but I don't have a formula to do that with. So what we do is we have to think about what we mean when we say this instantaneous rate of change or the slope of the tangent line. What we're going to do is we think of taking secant lines, okay, and we look at what happens when the secant lines get closer and closer. But I don't really have a choice. I don't have very many choices for what I plug in for x. Like if I want to approach 8, I can't put in 7.99. I'm limited to what I have here, okay? So what I can do is I can say, all right, suppose here's 8, here's 5, here's 11, and I have these, different values. One way that I can get the tangent line at this point is by looking at the secant line that connects 5 and 11, because those are the closest points I have on either side of 8. Okay, so I'm going to find the slope of the line that connects not 8 itself, but 5 and 11 together. So then that slope is 34.944 minus 8.118 over 5 minus 11. Okay, so I get negative 4.471. Okay.
Great, thank you.
Yeah, I always find it's a little bit challenging when they don't And when they don't give you a formula, then you're like, what do I do with data? So it can be confusing. All right, another homework question?
I got a question on that one.
Yeah.
What if they gave you the last, like if it was week 26 and you don't have any points before and after?
Then I would use weeks 23 and 26 and connect them together.
Okay. Okay. Thank you.
So the downside of that, right? So if I have a function that's sort of sloping down like this, okay, and I want to find the tangent line, say here, if I use the secant line between this point and this point, I know that I'm going to get one that's too steep, right? Whereas if I could go on both sides, I might get a secant line that sort of matches my tangent. And that's why, going on both sides of that point would be a little bit more ideal. But if you don't have that, you kind of have to use what's available. Okay. Any other homework questions? Okay. Well,
I'm
if
finding
not,
some.
what's that?
I'm gonna look for some.
Oh, okay. Okay. No hurry. I feel a little bit bad. When I was thinking about this homework day last week, I didn't really think about the fact that this was Memorial Day and we should be, out at parades not doing math, but
Here we are doing math.
here we are doing math. The problem is tomorrow's class and tomorrow's not the holiday. That's where we really run into trouble.
I have a question on 1.5, question 3. I know it's a super straightforward question. I'm just wondering how to tackle it.
Yeah.
Mainly just looking at a certain number and predicting what the graph is instead of typing in intervals into a calculator.
Okay, so here's how I would do this without actually graphing these on a calculator, which is certainly a viable option, right? You could graph y equals 3 times 1.53 to the x. And you could graph all these on a screen and see which matches up. But just to get sort of a sense for what each of these looks like, I know that if I take a graph of something like y equals 2 to the x, right, I get something that looks roughly like this. Okay. Now, I know from transformations that if you put a negative on the x, that reflects it about the y-axis. Okay, so I'm going to get something like that. And I also know from my properties of exponentials that 2 to the negative x is like y equals 2 to the negative 1 to the x, and 2 to the negative 1 is 1/2. Okay. So when I have these numbers that are smaller than 1, it's like taking an exponential that's bigger than 1 and reflecting it over the y-axis. Okay, so I know that this one and this one are going to be graphs that slope down instead of going up. Okay, so that starts to narrow it down. Now the next thing I do is I just look at the relative sizes, right? 2 to the x is a graph like this. If I looked at a graph of say y equals 10 to the x, okay, when you plug in a number, 10 squared is a much bigger number, right? So I'm going to get a bigger number. When I put in a negative, 10 to the negative 1 is 1/10 compared to 1/2, so it goes smaller, right? So I get something like this. So the bigger the base, the steeper the function, right? Steep going down and steep going up. Okay. So if I look at my three that are have a base that are, well, let's just compare these two real quick. If I compare these two, this top one has a bigger base, so it's going to go up more steeply. Now, how do I compare those two with this one? Well, if I compare 3 times 1.2 to the x, 4 times 1.2 to the x, they have the same base, but here I'm multiplying by a bigger number. Where that's going to make a difference is when x is 0, right? When x is 0, it doesn't matter what the base is, I'm going to get 1. So this graph here is going to have a y-intercept of 4 instead of 3. And the only one that does that is this g, sorry. I think it's k. I don't know, it's the black one, right? The black one, k. Okay, so this one is k. All right. Then out of the other two that are sloped up and going through 3, the steeper one is going to be the bigger base. So the steeper one is the red one, and the less steep one is the green one. Okay. And then these ones with a base that are smaller than 1 are going to be the ones sloped down. Okay. And it's kind of the same thing, right? 1/2 to the x is like a 2 to the negative x. Okay. And if I took 1/10 to the x, that would be like a 10 to the negative x. Okay. So the closer to 0 it is, the steeper it's going to be. Okay. So when I look at these two, the 0.7 is the smaller number. It's closer to 0, so I'm going to get the steeper graph. So out of the ones sloping down between the orange and the blue, the orange is the steeper one. The blue is the less steep one. Does that make sense?
Yes, it does. Thank you.
Okay. A for red, B, well, anyway, we already wrote it up. Okay, another homework question? All right, if you guys are good for now, I'm good for now. We'll save a little bit of time in class for additional homework questions too. So if something comes up, you can always hit the Ask Instructor button, but we'll also spend a little bit of time going over some of these in class.
Sounds
Alright,
good. Thank you.
All right. Have a good Memorial Day.
Hey, Dr. Meshes, how are you?